Hi, friends. It's over. We're done. We've finished. We've made it to the end of this series. I'm so happy that we created this Kubernetes Fundamentals series here in C# Corner. Today, my plan is to just go through all the topics that we explained since the first learning checkpoint. And yeah, I just wanted to say goodbye and thank you for watching this series. So let's get started, okay? The thing about Kubernetes, as you saw in this series, is that this is not a tricky or easy technology, right? You need to know a lot of things in order to take the most out of Kubernetes. So in the first learning checkpoint, we ended with the secrets topics. And here, we're going to start remembering about resource management. So resource management, as you might remember, is when you want to put some constraints on your applications, right? Maybe on the pod level, or maybe on the resource quota level, which is an object that you create to apply it to a specific namespace. However, the thing here is that you should strive for high compute density. Otherwise, your containers and pods, they're going to take all the resources in your clusters. Okay, so what are those resource types? The most common ones are CPU or memory or storage, and some others such as network bandwidth and CPU. So you create resource requests, or you can use and create resource limits, right? So for instance, in this code that I have here on the screen, this is a pod, right? This is a manifest, just a regular manifest file. And inside the container specification, you can add the resources that you want to use for that particular container, right? So resource limits, they can allow you to specify the maximum amount of resources that a container can consume. So this is for constraining, right? Constraining your containers. In that case, you use the resources field, and inside you can set some limits, right? For instance, in this code that I have here on the screen, this is limiting this container to use 1,000 millicores, which is one CPU, right? So, of course, it all depends on your particular requests and requirements, right? But yes, be sure to add some limits and ask for some resources when you're creating this kind of applications. And we saw resource quota objects as well. So this is an object. You create those resource quota objects by using a manifest. And inside the specification, you can set some limits in terms of CPU or memory, or even the number of objects that you can create for a particular namespace. Okay, so as you can see here on the screen, this manifest is creating a resource quota object named myRQ, and then we can apply this resource quota object by using kubectl apply, and we can get all the quotas by using kubectl get quota, and you can describe each of those quotas, right? So this is great. And let me do a little bit of management here in my other screen. Then we talked about, what was it? Multi-container pods, right? So multi-container pods are this kind of design pattern when you need to run more than one container in a single pod, right? So we talked about Dapper as framework for creating distributed applications, and that's just a small example of a technology that uses multi-container pods. So with that, we saw init containers. init containers, they allow you to implement initialization logic for your applications. Remember that I told you that those are pretty similar to autoexec.bat kind of logic. Remember autoexec.bat? So we used that in the old MS-DOS days for precisely initialization logic, right? So you can create those init containers. You can have a number of init containers. They're going to run on a sequence, and then your application will run. So those init containers are pretty useful for running and executing this startup logic that your application needs, right? So init containers, you specify that by using the init containers field inside your pod specification. So as you can see here on the screen, this manifest file is creating a pod, right? And this is defining a container, which is based on a fictitious image name. And it's adding an init container. That init container is based on the busybox 1.28 label. And this is running just an init container has completed its task. It's just echoing that on the OS, and that's it. This is just a silly example of init containers, right? So init containers, once they're running, you can query for all the container instances for all your pods by executing just a regular kubectl get pod, right? So in this case, this is just showing in the middle example is showing how many containers are running in that particular time. And it's telling us, you know what? This is initialization. This is in the init state, right? So this is running the initialization that comes from the init container. And once that's done, then the pod will be ready, right? So we saw sidecar containers. Sidecar containers are a helper logic for the application. You can be running an additional application for helping out the main application that is running on the pod, right? For, I don't know, maybe reverse proxy, for log management, for file sync, or monitoring and metrics, and so on and so on. So actually, the Dapper framework is an example of a sidecar container because Dapper is running alongside your application, right? So the thing about sidecar containers is that the sidecar application is running at the same time as your main application, right? So in this diagram that we are showing here on the screen, the sidecar, let's say that this is just a small example of an application that is reading for a volume. This is reading data from a volume, and then is, I don't know, maybe it's the output is some kind of status or notification or something. However, the clients or other services are requesting the main application logic. So you specify sidecar containers inside the same containers field, okay? There's no sidecar containers field in the pod spec, right? So you should add an additional container on the same pod. That's why containers is an array. You can define one or many containers in the same pod, right? So this is another example that has this other code. And of course, the font size is very small, but actually it's doing the same. It's defining another container that is running this script with while true. So that's why this is running all the time, right? So the font size is a little bit too small. And adapter containers. So adapter is when you want to make two compatible interfaces compatible. So this is for integration purposes. You can use the adapter design pattern. this is, again, this is another container running at the same time as your main application. An ambassador is when you want to implement a proxy or intermediary between the main application container and external services or systems. This is a very similar design pattern as the sidecar design pattern, right? So then we saw state persistence, right? We talked about containers and data. We talked about ephemeral volumes, which are a way of defining a storage place for your applications, right? So this is a storage abstraction. In ephemeral volumes is a way of, storing data, but as its name implies, it's ephemeral. So the state is going to be lost when the pod goes away, right? So those ephemeral volumes are created when the pod is created and deleted when the pod is terminated. So those are ephemeral volumes. And we talked about empty there as an example of an ephemeral volume. This is a very popular one. You just define inside the volumes field the name of the volume and empty there as its value. So in this case, in this example that I have here on the screen, the volume mounts field is referring to the my volume volume, right? To the is referencing the volume. So let's go back here to persistent volumes. That's another thing that we saw. Persistent volumes, instead of being ephemeral, persistent volumes, they store data in a long-lived, durable storage for your Kubernetes applications. So there are many persistent volume technologies that you can use, such as disks, NAS, cloud storage, and so on and so on. So this is a better option for storing your data instead of using ephemeral volumes. Of course, ephemeral volumes, they have their place. They're coming handy when you want to just temporarily store something, right? And persistent volumes is for the other way around. You want to store the data persistently. And so you define a persistent volume object by using the persistent volume kind of object in your manifest file. You can, of course, create a persistent volume by using kubectl imperatively. However, I think this is a better way to creating these persistent volume objects. So this is just saying to Kubernetes, hey, you know what? I want this volume to be located in that particular folder, right? In this particular file path. And I want 10 gigabytes of storage, right? In this case, it's gigabytes, not gigabytes, gigabytes, okay? So there are many, well, actually 4 or 5 access modes that we can use. This example is just using the read write once object. I'm sorry, access mode value, right? And then we created persistent volume claims. Those objects are requests for storage against a persistent volume, okay? So you create the persistent volume, and inside your applications, in your manifest, you ask for storage by using a persistent volume claim. So we talked about that. And so here's an example, right, of this. So in this pod specification, we have the volumes field, and of course, we have the volumes mount. However, this volume is referencing an existing, or is creating a new persistent volume claim. So this is gonna use the persistent volume claim that you created beforehand. So it looks like this. This is a persistent volume claim object. So you define this in a manifest file, you apply it, and then you can use it in your pod specifications, right? So as you can see, this is my PVC object that this other code is referencing. Okay. So yeah, PVs and PVCs and the relationship with pods is like this, right? So in your pod, you use a volume that it can reference a persistent volume claim, and the persistent volume claim or PVC is just referencing the PV, and of course that PV should be using, I don't know, maybe disk space, or maybe it's using NAS or whatnot. So then we talked about daemon sets as a way of running pods and ensuring that a specific pod runs on all nodes or a subset of nodes in a cluster. So this is useful when you want to, I don't know, maybe you want to execute this specific log collection component, or you need to run this, I don't know, monitoring agents, network management components, and so on, right? So we use daemon sets. We define daemon sets by creating a manifest file, such as the one that is right here. As you can see, the kind is daemon set. And then you specify the job specification. So then we talked about jobs. Remember the episode about jobs? Well, actually, those objects are pretty useful when you want to execute a finite task or batch process that runs to completion, right? So you have this, I don't know, this logic that you need to run it regardless of the time it'll take, right? So there are many use cases for jobs, such as batch processing, database migrations, data backups, machine learning, scheduled tasks, and so on. So we described some of the key fields for jobs. And then we talked about cron jobs as a way of scheduling jobs. Cron jobs, those are built on top of jobs. So the difference here is that you specify the schedule. Remember that? So you specify the cron expression about this cron job, about this particular schedule, right? So you should be careful about those cron expressions and their syntax, because I think that's the most tricky part about this, okay? And then Ingress, which was our previous session. Ingress was the last topic of this Kubernetes Fundamentals series. With an ingress, you can define how external traffic should be routed to the services within the cluster, right? So we talked about this. We can create ingress objects, and those ingress objects are based on ingress controllers. So ingress controllers are the ones that are running all the time, and they're watching the desired state of things, and they're applying the ingress object routes and rules that you specified, right? So ingress, the most common ingress controller, I believe, is the Nginx ingress controller, right? So that's why we use that. Of course, there are many others, such as HA proxy, traffic, Istio, and some others, okay? So since we've been using Minikube, right, in the entire series, you have to enable the ingress option in your Minikube cluster, okay? So that's why you have to execute Minikube add-ons, enable ingress, and that's gonna install and configure the Nginx controller, ingress controller, right, in your cluster. And then, of course, you can do that manually. But yeah, then you can create your Ingress objects by specifying a manifest file. So as you can see here on the screen, the Ingress object is of kind of, it's an Ingress, right? We can see that in the kind field. And the API version should be, well, at the time of this recording, is networking.k.io/v1. And here in the Ingress object, you specify the routing rules for your services that you want to expose, okay? And that led me to the end of this series, friends. Thank you. Thank you very much for coming and watching this series. I hope you've enjoyed taking this series as much as I've enjoyed being with you each week. Of course, not all weeks. We took a lot, some vacations, right, in the middle. And thank you for coming again. Be on the lookout for other courses and series here in C# Corner Live. And let me shamelessly plug some courses in LinkedIn Learning that I created. I recorded a couple of courses for LinkedIn Learning, and those will be available soon. So the first one is the exam prep for the Certified Kubernetes Administrator exam, and the other one for the Certified Kubernetes Application Developer exam. So those two are two training courses about how to pass those exams. Of course, you need to know Kubernetes. Those exams are pretty challenging, to be honest, because you need to do everything. You need to do a lot of things manually on a cluster. And of course, you need to know basically all the topics in the certification guidelines. Anyways, thank you very much, friends, and see you on the next series here on C# Corner Live. Bye-bye.